I can prove that 1 equals 2. I can prove that you owe me $1,000, that the moon is made of cheese, and that you are simultaneously alive and a sandwich. And all I need is one tiny, forbidden move dividing by zero. Do it once, and the entire edifice of mathematics politely falls over. You've been told your whole life that you can't divide by zero. Your calculator says error. Your teacher said you just can't. Nobody ever explained what actually goes wrong. It's like being told not to press the red button without anyone mentioning it launches the missiles. So let's press the button. Let's see the missiles. Because the reason behind this rule is far stranger and far more beautiful than anyone ever bothered to tell you. First, what does dividing even mean? Division is just multiplication walking backwards. When you write 6 divided by 2, you're really asking a question: what number times 2 gives me 6? The answer is 3, because 3 times 2 is 6. That's all division is, a question in disguise. Every division problem you have ever solved was secretly a multiplication problem wearing a trench coat, asking you to find the missing factor. So when we write 1 divided by 0, we're asking what number times 0 gives me 1? And here's where things get awkward. Picture a little question mark sliding along the number line, auditioning every number for the job. Try 5. 5 times 0 is 0. Not 1. Try a million. A million times 0 is 0. Try negative 7.3. Still 0. Try the number you're thinking of right now. I don't know what it is, but I promise, times 0, it's 0. Anything times 0 is 0. That's not a suggestion, it's the personality of 0. So there is no number that does the job. The answer to 1 divided by 0 isn't a weird number. It isn't infinity. It's that the question has no answer. We asked for a unicorn and the number line said, we don't carry those. There is simply nothing on the entire infinite line that can satisfy the request, and no amount of searching will ever turn one up. But maybe we're being too hasty. Maybe we can't hit 0 head on, but we can sneak up on it. This is the move mathematicians make when they're feeling sneaky, which is most of the time. What's 1 divided by 0.1? That's 10. 1 divided by 0.01 is 100. 1 divided by 0.001 is 1,000. As the denominator gets tinier and tinier, creeping towards 0, the answer rockets upward toward infinity. So maybe 1 over 0 is just infinity. Case closed. Everyone go home? Not so fast. We snuck up from the right side, the positive side. Let's sneak up from the left. 1 divided by negative 0.1 is negative 10. 1 divided by negative 0.01 is negative 100. 1 divided by negative 0.001 is negative 1000. From the left, the answer plummets toward negative infinity, falling just as fast as it climbed on the other side, but in the exact opposite direction. So we have a problem. If you approach 0 from the right, the answer screams toward positive infinity. From the left, it dives toward negative infinity. The graph of 1 over x literally tears itself in two at 0, one branch shooting up to the heavens, the other diving down to the basement. They never meet. They don't even wave at each other. The answer depends entirely on which direction you walked in, and an answer that changes based on your mood is not an answer. It's a horoscope. Okay, but maybe we're overthinking the geometry. Let's just be bold. Let's assume 1 divided by 0 equals some number. We don't know what it is, so we'll call it x. Brave, confident, doomed. If 1 over 0 equals x, then by the definition of division, 0 times x equals 1. Fine. But remember 0's whole personality? Anything times 0 is 0. So 0 times x is also 0. Now we have 0 times x equals 1, and 0 times x equals 0, which means 1 equals 0. And this is where it stops being a cute math puzzle and becomes a crime scene. Take 1 equals 0 and add 1 to both sides. Now 2 equals 1. Add 1 again, 3 equals 1. Keep going. Every number is now equal to every other number. The number line crumples up like a parking ticket and collapses into a single point. Your bank balance equals my bank balance equals the speed of light equals 17. Everything is everything. We've achieved enlightenment, and also bankrupted all of mathematics in the process. That is the disaster. That's why your calculator panics. One single division by 0, and the whole system loses the ability to tell any two things apart. If 1 equals 0, then every distinction you have ever relied on simply evaporates. So the calculator doesn't refuse out of stubbornness. It refuses to protect itself, and to protect every other answer it has ever given you. Now, you might think this is all very abstract and would never sneak up on you in real life. But it does, constantly. Have you ever seen one of those proofs that 1 equals 2 that looks airtight? Start with two equal numbers a equals b. Multiply both sides by a. Subtract b squared from both sides. Factor both sides. Then divide both sides by the quantity a minus b. Simplify, and out pops the conclusion that 2 equals 1. Ta-da! Every step looks flawless. Every step looks like something your algebra teacher would happily sign off on. Except, we said a equals b, which means a minus b equals 0. So that innocent-looking step where we divide both sides by a minus b, we divided by 0. We dress 0 up in a little algebra costume a minus b so it could sneak past security. Every single proof that 1 equals 2 has this exact same trick buried in it. There's always a moment where 0 puts on sunglasses, walks past the bouncer, and ruins everything. The math isn't magic. It's a pickpocket. Now here's a plot twist. We've been talking about 1 divided by 0. But what about 0 divided by 0? Surely if 1 over 0 is a disaster, 0 over 0 is an even bigger disaster. Actually, it's a completely different flavor of weird. 0 divided by 0 asks what number, times 0, gives me 0. And the answer is everything. 5 works. A million works. Negative 7.3 works. Every number on the entire line raises its hand. It's not that no number fits the job, it's that all of them do. Simultaneously, and they're all very enthusiastic about it. Mathematicians call this an indeterminate form, which is fancy talk for it depends. Unlike 1 over 0, which is simply broken, 0 over 0 is the situation where the answer genuinely depends on how you got there. This is the entire reason calculus has a job. There's a whole tool called L'Hopital's rule that exists specifically to walk into the room when 0 over 0 shows up and figure out which answer it actually wants to be in context. So 0 over 0 isn't no answer. It's too many answers. Please provide more information. It's the math equivalent of texting we need to talk. So far the story is dividing by 0 breaks everything. Don't do it. But mathematicians are not the kind of people who leave a forbidden door unopened. Someone said, what if we just allowed it? What if we built a universe where 1 over 0 has an answer? And we just deal with the consequences. Enter the Riemann sphere. Take the number line, that infinite straight road stretching forever in both directions, and bend it. Curl it up until the two far ends, positive infinity and negative infinity, swing around and meet at a single new point at the top. You've turned an infinite line into a sphere, with one special point at the North Pole, and we call that point infinity. Just one infinity, no positive or negative there, now the same place. And in this world, the rules suddenly work. 1 divided by 0 equals infinity, that single North Pole point. And 1 divided by infinity equals 0. It's clean. It's consistent. The disaster we saw earlier doesn't happen, because we redefined the whole playing field to make room for it. The contradiction that crumpled the number line never appears, because the rules were rebuilt from the ground up to expect this single point at the top. So why don't we all just use this and tell our calculators to relax? Because there's a price. On the Riemann sphere, some of your favorite algebra rules stop working. Things like infinity plus 1 or infinity minus infinity become meaningless. You've traded one set of forbidden questions for another. You bought the right to divide by 0, and the bill came due somewhere else. There is no free lunch, especially in mathematics, where the lunch was never real to begin with. So what does your actual computer do when you divide by 0? Because it doesn't burst into flames, despite everything I just told you. Computers follow a standard with the deeply romantic name IEEE 754. And the engineers who wrote it made some very deliberate choices. When your computer divides 1.0 by 0.0, it doesn't crash. It calmly returns a special value infinity. It's basically using a tiny pocket version of the Riemann sphere idea, baked right into the silicon of every device you own. But divide 0.0 by 0.0, our old indeterminate friend, and the computer returns something called NaN, which stands for not a number. NaN is the computer shrugging. It's the digital equivalent of I don't know, and I refuse to guess. And NaN has the most unsettling property in all of computing. NaN is not equal to itself. If you ask a computer whether NaN equals NaN, it says no. It's the one value in your machine having a full-blown identity crisis, and honestly, relatable. So let's bring it home. We're told you can't divide by 0, like it's a rule somebody made up to annoy you. But it's not a rule like jaywalking, where the action is perfectly possible and just frowned upon. It's undefined the way the question "what color is louder" is undefined. The words are all valid, but assembled in that order, they don't point to anything real. The question itself is broken. You aren't being denied an answer. You're being told there was never a sensible question to begin with. And the deepest lesson hiding in all this: you can build a system where dividing by 0 has an answer. People did, but you always pay for it somewhere else. Mathematics isn't a dusty list of arbitrary commandments handed down to ruin your afternoon. It's a set of choices, each one with consequences, all carefully arranged so the whole thing doesn't collapse into a single point and declare that you are, in fact, a sandwich. If you enjoyed watching mathematics nearly destroy itself, subscribe to Improper Integral for more visual math and science, and maybe leave a like, so the algorithm doesn't divide our reach by 0.